Okay, as you take a look at your Math 123 Chapter 5 exam review, you're going to notice the very first problem you got on number 1. You want to write the prime factorization of the number 68. So we just have to remember that prime factorization means to do a prime tree. And so when we're doing a prime tree, we're breaking down a number into our primes. So you just have to remember our prime numbers are the following. Our first prime number is 2, and the next prime number is 3, and 5, and 7, and 11, and 13, so on and so forth. And so we're going to break down our number into those primes right there. So you'll notice that the very first prime that I notice that goes into 68 evenly is the number 2, because 2 times 34 is 68. So I've broken that 68 down to the prime of 2 times 34. Now I'm going to go ahead and take another 2 out of 34, and 34 becomes 2 times 17. Now that I've done that, you're going to notice that those are all prime numbers, 2, 2, and 17. So that's when I stop right here, and I just write it into this form right here, which is 2 squared times 17. Okay, now the next number it wants me to do is it wants me to go ahead and find the prime factorization of 100. So again, breaking it down into its prime, I notice that 2 times 50 is going to equal 100. And then I got to break that 50 down further because it's not prime, so I notice that is 2 times 25. Now 25 is not prime also, so I go to my next prime. That goes into 25 evenly, that is 5 and 5. So now my prime numbers are all on the outside there, so that's going to be 2, and that looks like we got 2 to the second times 5 to the second. And so that would be the prime factorization of 100. Now the next problem says it wants us to find the greatest common divisor of 36 and 54. But what you need to remember about greatest common divisor is to find the greatest common divisor, you're going to find the intersection of the prime factorization sets. Remember that little upside down U symbol means intersection. So intersections of numbers the sets have in common. So I'm going to basically, what I'm going to do is I'm going to do a prime tree of 36 and a prime tree of 54. And then I'm going to take their two sets and I'm going to find the numbers that they have in common. So notice here's 36. I break it down to 2 times 18. And then 18 can be broken down to 2 times 9. And then 9 can be broken down to 3 and 3. So the prime factorization of this is going to be 2 to the second times 3 to the second. So there's the prime factorization of the number 36. And I come over here to my other number that I want to find the greatest common divisor with, and that number is 54. So I do its prime tree also. So notice that's going to be 2 times 27, which is 3 times 9, which is 3 times 3. So its prime factorization is just going to be those prime numbers, which is going to be 2 times 3 to the third. So once I've done those two sets right there, I'm going to take my two sets, and I'm going to find their intersection. So the intersection means the numbers that they have in common. So notice the numbers that these have in common. You've got 2 squared here, you got 2 to the first right there. So that means there's only one 2 to the first that is common in both of those. I notice I've got right here, I've got 3 to the second, and I've got 3 to the third. So the numbers that I have in common right there is just 2 of them, so that's 3 to the second. So I just go ahead and multiply that out. And I want to take 2 to the first times 3 to the second. That answer is going to be 18. And so that will be the greatest common divisor of those two numbers. So now this next problem, which is a story problem, says the following. It says a club has 54 male members and 45 female members. If the club is to have a contest where they're all male and all female teams competing, what is the most members a team can have? All teams must be of equal size and everyone must be on a team. Well, all we have to do is just remember to find the most members a team can have, you need to find the greatest common divisor of the two numbers as explained in problem number 4. Or in other words, I'm going to go ahead and do the prime factorization, and I'm going to find the intersection of my prime factorization. So I take those two numbers right here, which is 54 and 45, and I'm going to do a prime tree of those two. So when I do my prime tree, I've got 2 times 27 is 54. I break down the 27, 3 times 9, and then 3 times 3. And so you're going to notice that those prime numbers, which are on the outside here, that is going to be your prime factorization. And so that's going to come out to be 2 times 3 to the third, because there's 1, 2, and 3 3s. And I go and do my prime tree of 45. So 45 breaks down to 5 times 9. And then I break down that 9 further to 3 times 3. So those numbers on the outside are your prime factorization. So that brings up the set 5 times 3 squared. So now I just got to find the intersection. And remember this little symbol right here means intersection. So I got to find the intersection between those 2 points. So to find the intersection of those 2 points, I got to find the numbers that are common in both those sets. So you'll notice there's a 2 here, there's no 2 here, so that's not in common. I've got 3 to the third, I've got 3 to the second, so that means that 3 to the second is in common in both of them. And so I take 3 to the second, I get my answer of 9. So that would be the total number of members a team can have, which would be 9. Okay, now on this next problem on number 5, it basically says that it wants us to find the LCM, also known as the least common multiple, of 24 and 40. Well, to find the least common multiple, you need to find the union of the prime factorization sets. So we're going to go ahead and do the prime tree again. And remember, this U symbol means union. And union means to multiply all the numbers in the sets together, eliminating any duplicates or repeats, if that's the way you want to think of it. So what I'm going to do is I'm going to do my prime factorization of those 2 numbers right here. So I've got the prime factorization of 24. So 24 breaks down into 2 times 12. And that 12 can break down further to 2 times 6. And that 6 can break down further to 2 times 3. So you're going to notice the numbers that make up my prime factorization set. I've got 3 2s and 1 3. So that set becomes 2 to the third times 3. I'm going to union that with the prime factorization of 40. So 40 becomes 2 times 20, which is 2 times 10, which is 2 times 5. So those outer numbers that are prime, that is my prime factorization set. So you'll notice that equals 2 to the third times 5. Okay, now that I've done that, I'm going to go ahead and multiply all those numbers together and eliminate the repeats or the duplicates. So when I do that, you're going to notice that here I'm going to multiply 2 to the third times 3. So here's 2 to the third times 3. This 2 to the third over here is a repeat or a duplicate, so I don't multiply by that. And then I've got this times 5. So now all I have to do is take 2 to the third, which is 8, times 3 times 5. That's 24 times 5, which is going to give you the answer of 120. And so that is how you find the least common multiple. Now this next problem says it wants me to find each sum. We've got 4 to the 3/4 plus negative 3 to the 1/6 plus negative 4 to the 3/5. So if you want to do it out the long way, you're just going to add all the numbers separately and your fractions separately. So here's a 4. I'm going to add the negative 3. I'm going to add the negative 4. And when I add 4 plus negative 3, I get 1. And 1 minus 4 is going to give me this first number, which is negative 3. So now that I've done that, I'm going to add my fractions in there. So you're going to notice my fractions are 3/4 minus 1/6 minus 3/5. Well, to do that, I got to get a common denominator. My common denominator is going to be 60. So I'm going to go ahead and change this first one to 60. So I have to multiply the 3/4 right here by 15 over 15. So 3 times 15 is 45. And 4 times 15 is going to be 60. And then I'm going to change this to 60, this 1/6. So notice that's going to be 1 times 10 all over 6 times 10. So 1 times 10 is 10, 6 times 10 is 60. And so then you've got minus 10 is 60. Okay, and I'm going to change the 3/5 to have a common denominator of 60. So I'm going to take 3 times 12, which is going to be 36. and 5 times 12, which is going to be 60. So now when I combine those fractions together, I'm just going to take 45 minus 10, which is 35, and 35 minus 36 is going to equal -1. And then I'm going to keep my common denominator, which is 60. I add those together, and I get -3 and 1/60. Now remember, if you want to, you can also do this on your calculator. So if you look at your calculator right here, you can go ahead and just type this directly into your calculator, and then just go ahead and find the answer that way. So notice, here's my problem. So if you take your calculator, you're going to go ahead and take your calculator and hit alpha, and then hit F1, and then you're going to hit number 2, and that's going to give you that mixed number. And then you're going to go ahead and type in 4. You're going to arrow over to the numerator, type in 3. You're going to go to the denominator and type in 4. And then on this next one, we've got plus, and then we're going to hit our negative sign here. And we've got 3. We need to go ahead and do alpha F1 and do number 2. So we've got our mixed number again. So we've got 3. Then we're going to arrow over and type in 1. Arrow down, type in 6. And then arrow over again. And we've got plus, and hit your negative key. And then we're going to go ahead and hit alpha. F1 again, hit number 2 for your mixed number. And you've got 4. And we're going to type in 3. And then underneath that is going to be 5. So once you're done typing that in, all you have to do is just hit enter. And you're going to notice that it gives you that answer as an improper fraction, which I'll accept that answer. But if you want to change it, you just hit alpha, F1, hit number 3, and that'll change that to mixed number, which is -3 and 1/60. So you can also just do that problem on your calculator. So on this next problem right here, on number 7, it says set up a proportion of fractions with the ounces in the numerator and brownies in the denominator. So as you read your problem, it says the recipe calls for 4 ounces of unsweetened chocolate for 14 brownies. How much of unsweetened chocolate is needed to make 36 brownies? Well, you're going to notice the very first thing you run into is 4. So you put that in your numerator. We're going to set this up as a proportion. So you got 4 ounces, and that is for, in your denominator, 14 brownies. And then we're going to go ahead and do equals. And we don't know the number of ounces we need for 36 brownies, but notice that's in your numerator. And you're going to put 36 brownies in your denominator. So now I'll go ahead and cross multiply. So we're going to take 4 times 36, all equals 14. And we're just going to call that x, because that's the question x. We don't know how many ounces there are. So now we just have to solve this proportion. And we're going to go ahead and take 4 times 36, and 4 times 36 is 144, all equals 14x. Divide both sides by 14, and when we divide by 14, that comes out to our answer of 10.28 ounces is how much sweetened chocolate that you would need for 36 brownies. Okay, now on number 8, you're going to notice there's 2 ways to do this. You can put in calculator exactly as it is written, or follow your order of operations to solve. So remember, your order of operations says the following. Your order of operations say, whenever we're solving anything, we've got to do what's inside of the parentheses. Then we've got to do exponents and powers. We've got to do multiplication and division from left to right. And then we have to do addition and subtraction from left to right. So that's your order of operations. So we'll do the order of operations first, and then we'll put it into our calculator and see how it's the exact same answer. So my order of operations say do what's in parentheses first. So here's the set parentheses right here. I got 6 times 2 times 2. So 6 times 2 is 12, and 12 times 2 is going to be 24. So now I've done what's inside of my parentheses. So notice there are no powers, there aren't any exponents. So I'm going to go and do my multiplication right here. I got 8 times 10, that's going to give me 80. And I still have my minus, and I got 24 divided by 8, which is going to be 3. Now following my last thing, I got to do addition, subtraction, left to right, and 80 minus 3 is going to be 77. So that would be your answer. And you're going to notice if you're going to use your calculator for it, just go and type it in exactly as it's written. So you can type in 8 and hit times 10 and minus, and then you're going to put parentheses. You got 6 times 2 times 2, and then we've got divided by 8. So type it in exactly as you see it, and just hit enter, and you'll get the correct answer. So either way that you do it, it's perfectly fine. So same thing on number 9. You're just going to go ahead and, on number 9, it says we've got 10 minus 3 minus 10, and then we've got in parentheses 10 minus 7 plus 5 times 8. So if you follow your order of operations on this problem right here, you're going to notice here's your parentheses right here, 10 minus 7, that's going to give you 3. I got 10 minus 3 plus 5 times 8. Well, there's no powers or exponents I have to worry about, but I do have to do this problem. Multiplication division's next, so I got to do that one next, so that's going to be 40. So now that I've got all addition and subtraction, just go from left to right. So I got 10 minus 3 is going to be 7, and 7 minus 3 is going to be 4, and 4 plus 40 is going to be 44. Now you're going to notice if you just type that in exactly as you see it into your calculator, you'll still get the correct answer. So if you take 10 minus 3 minus, and then put parentheses around your 10 minus 7, you got plus 5. Oops, forgot to put my end parenthesis there, so let me go ahead and insert that. So you got parentheses, and you got plus 5, and times 8. So type it exactly as you see it, hit enter, and you'll get the same answer of 44. So on this next problem, on number 10, we want to go ahead and simplify what are called radicals. Radicals are roots, and roots basically means that's our radical symbol. So whenever you see this little symbol like this, that's a radical symbol. So to be able to simplify these, you got to remember all your perfect squares or your perfect square radicals. And so I make this list for you. So you'll notice that we got the first one, square root of 4 equals 2, square root of 9 equals 3, square root of 16 equals 4, square root of 25 equals 5. Got the square root of 36, it's going to equal 6. And then we got the square root of 49, it's going to equal 7. Square root of 64 is going to equal 8. Square root of 81 is going to equal 9. And then your last one that you have, and this is square root of 100 is 10. Square root of 121 is 11. Square root of 144 is 12. Square root of 169 is 13. Square root of 196 is 14. Square root of 225 is 50. So that's your perfect square list that you need to remember when you're simplifying radicals. Or in other words, I'm going to find a number on my list that goes into 40 evenly, and I want to find the largest one. So notice I point out, always find the largest root from the square root list. So notice in 40, I've got this number right here. So I've noticed that 4 goes into 40, and that's going to go in there 10 times. I'm going to break that apart as the square root of 4 times the square root of 10. So the square root of 4 answer is 2, so that changes to 2, and the square root of 10 stays the same, and that will be your answer of 2 square root of 10. Now this next one right here, on number 11, I got the square root of 125. So I got to find the biggest number on my list over here on the right hand side that goes into 125 evenly. So I notice that if I look at the square root of 25, that goes into 125 because 25 times 5 is 125. So notice when I break this down, they both still have their square root signs. It's the square root of 25 times the square root of 5. Now when I take the square root of 25, that answer is 5. And then this other one doesn't simplify, and so that stays as the square root of 5. Now in this last root problem, we got the square root of 7 plus the square root of 28. So notice on this one right here, again I want to break this down. Notice the square root of 7 is not on my list, so I just leave it the same. But the square root of 28 is the square root of 4 times the square root of 7. And the square root of 4 becomes 2 square root of 7. So notice there's a 1 there, even though I can't see it. So 1 plus 2 is going to be 3. That answer is going to be 3 square root of 7.